Hey there. I don't think that's the first page. It's not. Sorry. So today we're taking our inequality lesson one step further and talking a little bit more about solutions to those inequalities. And here we're just again in one variable. Not in my pen. Oh gosh. Okay, we're still one variable, which generally for us today is going to mean a number line. Okay, one variable. When we have two variables, then we'll be in a coordinate plane. For right now, we're just talking, a number line where we're going to highlight values and shade, and that's one variable. When we do two variables, then we'll be in an XY coordinate plane and draw lines and shade. All right, but that's not today. So let's find and interpret solutions to inequalities in one variable. Okay, beginning. In your warm-up, you have this written down on your page. Make some solutions to the inequality y is less than or equal to 9.2. Okay, 9.2 is somewhere over here. So I'm going to write some solutions. My answer can be anywhere on that number plane. That's not how we do things in math, though. I'm going to include, that means that y can be equal to 9.2 or y can be smaller than 9.2. So because it can be equal, I need to put a dot on 9.2. And then I'm just going to use I can use a marker. Pretty thick marker. I'll erase it. My solution can be anywhere that's so thick below 9.2. That's a little ridiculous. Let's move my head. Okay, I like the marker idea, but that was just a little too thick. So my solution can be anywhere in there. I can say 0 is a solution because 0 is less than or equal to 9.2. I can use -1 because that's less than or equal to 9.2. I can use -10, less than or equal to 9.2. I can use 9 because that's less than or equal to 9.2. So many different options, right? Let's erase that big thick line. Okay, the next one was solve the inequality 7, 3 minus x is greater than 14. There's two different ways you can solve this. I'll go ahead and represent both, but I don't normally represent both. I can distribute that first. I get 21 minus 7x is greater than 14. And then I can subtract 21 from both sides, and I get negative 7x. Negative 7x is greater than 14 minus 21 is negative 7. I'm going to flip that. Nope, I'm not. Dang it, I did not want to go through this rule on the first day. When I divide both by negative, I actually get x is less than positive 1. Whenever you multiply or divide with a negative in inequalities, your inequality has to flip. Okay? Let's see. Yep, let's try this another way. I personally like dividing both sides by 7 first. And I get 3 minus x is greater than 2. I'm going to add x to both sides and subtract 2 from both sides. And I get x is less than 1. Or 1 is greater than x. Pac-Man is eating the 1 for both of them, so it doesn't matter which way you do it. But you do need to remember when you divide by negative, your inequality has to flip. Kind of annoying. Okay, let's go ahead and plot this. So x has to be smaller than 1. It cannot be equal to 1. It has to be smaller than 1, so I'm going to put an open dot there. That just signifies that x cannot be equal to 1. but it can be equal to all numbers smaller than 1, like 0, like 1.9, like -5, like -10, etc. X can be any number smaller than 1, any number at all. All right, cool, let's move on. This lesson is a little long, so you can always push pause and go take a break. Okay, we already did this. Yay. All right, how did you know the value you chose as a solution? I knew it was a solution because, I thought I changed that. It was in the shaded area of the number line. Also, because the value I chose made a true statement. Ooh, let's do something. Okay, go back up. Let's see. For this one, let's remember that we chose a -5. Let's put it into this equation and make sure it works. 7 times 3 minus -5 greater than 14. Let's see if it's true or not. That's a question mark. 3 minus -5 is 8. 7 times 8 is 15. Is 15 bigger than 14? Yes, it is. So it's a solution to the equation. Okay? Any number that is in the shaded area of that number line, which is right here in red, any number in that shaded area is a solution. What do you notice about all the points that are on the line? I don't know what that one's asking about. Sometimes I'm just not sure what the curriculum's asking for. What do you notice about all the points? Oh, they're all to the left. All to the left side. On the number line, we can see that the solutions are values that are less than 1. Are all these values form the solution set to the inequality. Solution set is a very important vocabulary words. Is there a way to write the solution set concisely without using the number line and without writing out all the numbers that are less than 1? Yes, I write x is less than 1. Does the solution set have anything to do with the solution to the equation? Yes. All numbers less than 1 make the statement true. Okay, it's in the solution set. Why does the solution set to the inequality involve numbers less than 1? Because they make the statement true. Okay, it's that simple, really. All right, so we're going off to an orchard. A teacher is choosing between 2 options for a class field trip to an orchard. Do you remember when we used to be able to go on field trips and leave campus? At Orchard A, admission costs $9 per person and 3 chaperones are required. At Orchard B, the cost is... I got interrupted. Sorry, where was I? At Orchard B, the cost is $10 per person, but only 1 chaperone is required. At each orchard, the same price applies to both chaperones and students. So here it's $9 per person, and we have to pay for 3 chaperones. Here it's $10 per person, but we only have to pay for 1 chaperone. So which orchard would be cheaper to visit if the class has 8 students? So here we're doing 8 students plus 3 chaperones is 11 times 9 is $99. Okay? The other one is 8 students plus 1 chaperone is 9 times $10 a student is $90. So Orchard B would be cheaper, right? Are you guys following along with me or trusting everything I do? I would never recommend you trust everything I do. So Orchard B. How about 12 students? So 12 students plus 3 chaperones is 15 times $9 per person, $135. Or you have 12 students plus 1 chaperone is 13 times 10 is 130 students. So B still. How about 30 students? I've got 30 students plus 3 chaperones times $9, $297. Or 30 students plus 1 chaperone. 31 times 10 is, did I do something wrong? I think I'm supposed to get Orchard A for that last one. 30 students plus 3 chaperones, 33 times 9. Okay, 30 students plus 1 chaperone. I still have B. Cheaper. Oh no, that's A. Haha. I don't even want to talk about it. I don't know what I was thinking. I was confused. A is cheaper. A is cheaper. B is cheaper. B is cheaper. A is cheaper. All right, moving on. To help her compare the cost of her 2 options, the teacher first writes the equation 9 times the number of students plus 3 equals 10 times the number of students plus 1. And then she writes the inequality 9 times number of students plus 3 is less than 10 number of students plus 1. Okay, what does N represent in each statement? I've said it a few times. Number of students. In this situation, what does the equation mean? That is where the orchards, I'd say the cost of the orchards is equal. So how many students you would need to go where it doesn't matter which orchard you go to. The cost is equal. Okay, and what does the solution to the inequality there tell us? It's going to be when the cost for orchard A is cheaper. Because this is orchard A less than orchard B. So that inequality would be the cost for orchard A is cheaper. Now graph the solution to the inequality on the number line. Be prepared to show or explain your reasoning. I'm going to come up here. First, when I'm graphing, I take the inequality and graph it. Not on this one though. I'm going to take the inequality. I said inequality, didn't I? So I have 9 n plus 3 is less than 10 n plus 1. Let's go ahead and distribute. 9n plus 27 is less than 10n plus 10. Yep, just doesn't look right. So I'm going to subtract 9n from both sides, and I get n. I'm going to subtract 10 from both sides, and I get 17. So then I write it this way, when n is greater than 17. So here, let's go ahead and, I don't know, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Remember, it's open dot, and then we shade to to the right because n is greater than 17. Okay, so what does the solution tell us? Orchard A is cheaper, so when the number of students is greater than 17, Orchard A is cheaper. Okay, cheaper for Orchard A when the number of students is greater than 17. All right, and our number line, sorry, this thing does that twice. Good job, good job. Maybe it's when I take my pen away. Okay, so my number line is graphically showing the answer, open dot at 17 because it's just greater than, not equal to, and arrow to the right. Cool? All right. Okay, so part-time work. To help pay for his tuition, a college student plans to work in the evenings and on weekends. He's been offered 2 part-time jobs, working in the guest services department at a hotel and waiting tables at a popular restaurant. The job at the hotel pays $18 an hour and offers $33 in transportation allowance per month. The job at the restaurant pays $7.50 an hour plus tips. The entire waitstaff typically collects about $50 in tips each hour. Tips are divided equally among the 4 waitstaff members who share a shift. It's a lot of information. So the hotel is $18 per hour plus $33 in transportation. The job at the restaurant pays $7.50 per hour plus tips. Okay, and that is typically, so I guess I should erase that, tips, which are typically $50 divided by 4 per hour. Okay, so that's how much we're making. Let's see where we're going with this. The equation 750h plus 50 divided by 4h equals 18h plus 33 represents a possible constraint about a situation. Okay? There we are. Solve the equation and check your solution. All right? So I'm going to take this 750 plus 50 over 4, because those are like terms. 750 plus 50 over 4 is 20h equals 18h plus 33. Subtract 18h from both sides. I get 2h equals 33. Divide both sides by 2. My pen just got really slow. So h equals 16.5. All right, check my solution. That means I plug 16.5 in. To the equation and make sure I get a true statement. Whew. I hope you pick up your calculator and go ahead and crunch this number. So I'm doing 7.5, parentheses 16.5, close parenthesis, plus parenthesis 50 divided by 4, parenthesis 16.5. So the left side of my equal sign equals 330. 18 times 16.5 plus 33 equals 330. I checked my solution and it worked. So solve the equation and check your solution. Here is a graph on a number line. Okay, put a scale on the number line so the point marked. That's a terrible scale. 17. So we're going to make this at 16 and a half. That seems good. So this is an open dot at 16. So that circle represents the solution, okay? Right there. We're going to be using this in a second. So does one job pay better if the student works fewer hours than the solution you found earlier? If so, what job? I have to sneeze. Whew. So does one job pay better if the student works fewer hours? So yeah, actually the hotel job pays better if you work less than 16.5 hours. So less than 16.5 hours would be 750 times, let's do 10 hours, plus 50 over 4. Oh, that's the hotel job. Nope, the hotel job, sorry, is 18 times 16.5 plus 33. Sorry, 18. If I pick a number smaller, let's say 10 hours. If I only worked 10 hours, let's say 10 hours, the hotel job would be $213, and the restaurant job would be plus $200. So this just tells us that if a student works fewer hours than the solution we found, which job pays better? The hotel job pays better. If the student works more hours than the solution you found, which job? And that would be the restaurant job. It would be the other one. And I just plugged in some numbers and checked it out, okay? And you can do that too. Be prepared to show how you know. So I found the pay for both jobs using numbers that are less than 16.5. Okay, I tested. I tested numbers. Less than 16.5. And I got hotel. And then I tested, goodness, numbers more than 16.5, and I got the restaurant job. Okay, I just tested. So here are two inequalities and two graphs that represent the solutions to the inequalities. Inequality 1 is that with less than. Inequality 2 is greater than. So put the same scale on each number line just like we did before. 16, 17, 18, 15, 14, and that's going to be for both of them because we want to compare both of them. So the circle represents the number of an hour. Match each inequality with a graph that shows the solution. Now we said when we picked numbers smaller than, which one did we do? So numbers less than, we got the hotel. And this is the hotel. So when we tested numbers smaller than, we got the hotel. So that would represent graph B. If I go back up here and read it, we tested numbers less than 16.5 and the hotel was more money. And then we tested numbers greater than 16.5 and the restaurant. We made more money. We made more money at the restaurant, and that was graph A. Okay. So let me change colors. If I test smaller numbers, like I tested 10, we found that this graph right here is a true statement. So if I remember, when I tested 10, I got the hotel was 213 and the restaurant was 200. The hotel was 213 and the restaurant was 200. So when I tested 10, since all of this is shaded in, it's a true statement. The hotel was greater. Okay, when I test 10 here, okay, it's not true. 10 is not part of the solution because 10 is way down here. Here, 10 is part of the solution because all the numbers less than 16.5 will make a true statement. Okay, if I test, let's just test 20, a number way bigger, 7.5 times 20 plus 50 divided by 4 times 20. So this would be the restaurant with 20 is 400. And the hotel, 18 times 20 plus 33, 393. So 20 is way up here. So when I test numbers bigger than 16.5, it makes for a true statement that the restaurant, you make more money at the restaurant than you do at the hotel. So all of these make for true statements. And I left some room for me to work. All right, so there's a mistake on this slide that I couldn't fix. Let's find it. Okay, so solve this equation and check your solution. I'm going to do it up here. I have negative 4 times x plus 3 over 5 equals 4x minus 12. Okay, I don't like fractions, so I'm going to multiply everything by 5. And that cancels this one out. So the left side of the equal sign, the 5 is gone, and then the right side, I multiply it through. 20x minus, I think it's 60. Yep. Okay, now I'm going to distribute that 4. Add 4 to both sides. Add 16 to both sides. Divide both sides by 24. I think that's 1/6. Yep, so x equals 1/6. Okay, so that's solving. Now, number 2 says consider the inequality, and they've written an equality, so I need to fix that. This would be less than or equal to, okay? So consider the inequality. Choose a couple of values less than 2 for x. Are they solutions to the inequality? Well, that's weird. I think I might have made a mistake up here. Negative 4 minus 12. I think I might have made a mistake. The book has x equals 2. I'm going to push pause and see if I can find my mistake, because you guys don't have to watch me do this. That took way longer for me to figure out. Right here. That's 60. I'm adding 60 to both sides. and I get negative 12 plus 60, which is 48. Okay, divide by 24 divided by 24, I get x equals 2. All I did was recopy this wrong. So it's 60, and then I add 60 to both sides. Whew, x equals 2. Okay. I really thought I messed that up really bad. Just slightly bad. All right, so consider this inequality. Choose a couple of values less than 2 for x. Are they solutions to the inequality? I'm going to choose 0 because I know that's smaller than x and it's easy to figure out. So I have negative 4. If x is 0, that's 3 over 5. Is that less than or equal to 4 times 0, which is 0, minus 12? Yes, because I have negative 4 times 3, which is negative 12, divide by 5, which is going to be smaller than 12. It's negative 2.4. Negative 2.4 is smaller than negative 12. Okay? Is it a solution to the inequality? Yes. Yes, it is. Oh. I really shouldn't record videos at this time of the day. Sometimes negatives are confusing. That's a 0. That's a 2. I'm going to test 0. And my question here is negative 2.4 smaller than negative 12. Well, the further you get away from the 0 on the number line, the smaller it is. So negative 12 is way down here, and negative 2.4 is somewhere over here, and that is a false statement. It's not a solution. Okay? So that means the other side of the inequality is a solution. Let's test 4. Okay, negative 4 times 4 plus 3 over 5 less than or equal to 4 times 4 minus 12. 4 plus 3 is 7. 7 times 4 is 28. Divide by 5. I have 5.6 less than or equal to, oh my goodness, I forgot the negative. 4 plus 3 is 7 times 4 is negative 28. So negative 5.6. And here I have 16 minus 12, which is 4. Is negative 5.6 smaller than 4? Yes. Yes, it is. Okay. So when I did this, that was a big old no. And I tried x equals 4. And that is a solution. 2, is that a solution? Yes, let's try it just to make sure. Negative 4, 2 plus 3 over 5. 4 times 2 minus 12. So 2 plus 3 is 5 times negative 4 is negative 20 over 5, which is negative 4. Here I have 8 minus 12, which is also negative 4. So it is a solution. So I want to dot and shaded all the numbers to the right. Okay? We tested 4, it was a solution. We tested 0, it was not. So 0 should not be in my shaded portion, and 4 should. I have a closed dot here because 2 is a solution. 4 is a solution. 10 is going to be a solution. Okay. Okay, I think there's one more example in here, and I'm going to go ahead and do it. I know it's a long, oh my goodness, stop. I know it's a long lesson, but it's complicated. I want to make sure that we all feel pretty comfortable. because this is our fifth activity. We'll usually only have 3. So let's consider this inequality. Let's look at another way to find its solutions. Use graphing technology, graph on the same coordinate plane. Okay, pause for a second. So you can actually go to this in the electronic student version of your curriculum. So yours says, use graphing technology to graph y equals negative 1/2 x plus 6 and y equals 4x minus 3. The solution to this system of equations is 2, 5. 2, 5 works for both of them. Use your graphs to answer the following questions. Find the values of these 2 equations when x equals 1. Well, right here I've got x equals, and I can drag this until x equals 1. So for the first equation, the solution when x equals 1, y equals 5.5. And for the red equation, when x equals 1, y equals 1. You can write that into your book. What value of x makes both equations equal? Well, that's what we said earlier. It's 2, 5. So where the 2 equations cross is at 2, 5. That ordered pair makes both solutions true. Okay, it's the value where they're equal. For what values of x is negative 1/2 x plus 6 less than 4x minus 3? Okay, for what values is it less than? So when x is greater than 2, it's going to be over here, we'll just say it's 3. Y is 9 on the red, and y is 4.5 on the black. Okay, so this equation is less than this equation, which is what it's asking us. And then for what values of x is the first equation greater than the second equation? Well, that's when x is going to be less than 2. Any values less than 2. Okay, we could even just say 1, which we already did, or 0. When x is 0, y is 6, or y is negative 3. Okay, so the solution, what is the solution to the equation, first equation is less than the second equation? It's where x is less than 2. Okay, when the first equation is less than the second equation. Sorry, is greater than. When the first equation is less than the second equation. For what value of x? I got that backwards. There we go. That is when the black equation is going to be less than the red equation. All right? Pretty cool. Pretty cool. Okay, that was a lot. I'm going to just cut it off. Good job.